Hello everyone. In this video, we are going to discuss about exercise question 3.11 from the chapter Motion in a Straight Line of class 11 physics. Read each statement below carefully and state with reasons and examples if it is true or false. That is, we just want to state whether these A, B, C, D examples, if they are true or false. So you see, it is given that we are considering a particle which is in one-dimensional motion. This is very important because the same thing for a two-dimensional or three-dimensional motion would be different. So here we are considering a particle in one-dimensional motion. This is important. So a particle in one-dimensional motion with zero speed at an instant may have non-zero acceleration at that instant. Is it true or false? You see, it is a true statement. Right. Why? Because you see, when an object is thrown vertically up in the air, the speed becomes zero at the maximum height. However, see, at the maximum height, its speed becomes zero. But its acceleration will be equal to the acceleration due to gravity, which is always acting in the vertically downward direction with a value g equals 9.8 meters second raised to minus 2. So a particle in one-dimensional motion, see the vertically upward motion, it is a one-dimensional motion. So in that case, at the maximum height, the particle is having zero speed, but it is having a non-zero acceleration, which is equal to acceleration due to gravity. So it is a true statement. Now let us see the next one. Then a particle in one-dimensional motion with zero speed may have non-zero velocity. It is a false statement. Why? Why? Because we know that velocity is actually simply the speed with direction. That is, speed is the magnitude of velocity. So if speed is equal to 0, then velocity also will be equal to 0. So it is given that it is having a non-zero velocity with zero speed, so that is a false statement. Now see the third one. See, a particle in one-dimensional motion with constant speed must have zero acceleration. You see, the particle in one-dimensional motion, that means the particle is moving in a particular direction with a constant speed. So direction is a constant. Okay, it is moving in a particular direction, so direction is a constant, and speed, it is also a constant. That is, speed with direction, which is velocity, is a constant. When velocity is a constant, then acceleration will be equal to what? 0. Because acceleration comes into play only when there is a change in velocity. So here there is no change in velocity, so 0 acceleration. That means this is a true statement. For example, you just consider a car moving on a straight highway with a constant speed. It is moving in a particular direction because it is in the one-dimensional motion. So it will be having a constant velocity. Acceleration is defined as the rate of change of velocity. Since there is no change in velocity in this case, acceleration of the car will be 0. It is true only if we consider a particle in one-dimensional motion. For example, if you consider a particle in uniform a circular motion, in that case, though the speed is a constant, its direction of motion continuously varies, and it is having an acceleration. That is, the circular motion is an accelerated motion. So this statement is true only if we consider a particle in one-dimensional motion. Now let us see the last one. A particle in one-dimensional motion with positive value of acceleration must be speeding up. You see, it actually depends upon the coordinate system taken to explain the motion of the particle. That is, if you consider, I am taking this as origin, then I am taking this as the positive direction, and I am taking the vertically downward one as the negative direction. So if you consider a ball which is moving in the downward direction, consider a ball which is moving in the downward direction. It is a one-dimensional motion, or a particle moving in the downward direction, which is a one-dimensional motion. So in this case, see, it is given that with the positive value of acceleration must be speeding up. So you see, in this case, its acceleration will be acceleration due to gravity, which is in the downward direction, so negative. So here the acceleration will be negative, but we know that when this object is, in the vertically downward direction, its speed actually increases. So when we consider the vertically downward direction, it is speeding up, but its acceleration due to, its acceleration is negative. So when an object is speeding up, it is not required that its acceleration must be positive, and vice versa. That is, if you are having a positive value of acceleration, it doesn't mean that it is speeding up, because it actually depends upon the coordinate system that we are taken to explain the motion of the particle. That is, if you consider this point as x equals 0 and the vertically downward direction as positive direction. Suppose you are considering the vertically downward direction as positive direction and vertically upward direction as negative direction. So in this case, suppose you are considering a particle which is moving in the upward direction, so it is in the one-dimensional motion. We know that a particle is moving in the upward direction. Suppose it is in free fall motion, it is thrown in the upward direction. So that time its speed actually decreases with respect to time. Okay, in this case its speed decreases with respect to time. But what about its acceleration? Its acceleration will be equal to the acceleration due to gravity, which is acting in the downward direction, that is along the positive direction. So here acceleration due to gravity will be positive, but the speed of the object is decreasing. Okay, so you see this statement actually depends upon the coordinate system that we are choosing to explain the motion of the particle. So in this question, we have discussed about exercise question 3.11. I hope it is clear to you. Thank you.